go to a lot of electrical classes, talking about Ohm's law and how you can sit down and calculate the current and voltage to drop. And I've done it. I was in the classroom as a private trainer 6 years and state school system for 15. And in electrical class, you probably got introduced to Ohm's law. This is not too scary. Then this is actually a workbook I used to use, and I feel guilty that why in the world I put people through this. That's what you did back then. I want to kind of make the point that this is really not necessary to get bogged down in this. It's simpler. This is one that I have to live with this the rest of my life, that I made people struggle through that for an hour or two. The thing is that Ohm's law is based on resistance. Of course, resistance controls current. Resistance goes up, current goes down. Resistance goes down, current goes up. It's all good stuff. But when you open the hood of a car, you don't see a little squiggly line. We look at Ohm's law, we just put a squiggly line to represent some kind of a load. And but out the hood of a car, I don't see a lot of resistors. That's supposed to represent a resistor. I have electrical loads, but here's a power window motor laying right here. Somebody tell me how I'm supposed to calculate the resistance of this. I've got I don't know, 3 or 4 wires here. Where do I start? This is a load that's going to resist current, but I have no effective way of measuring what the resistance is. I can put it into a car, power it up, and measure the current. If I know what the current should be, that should be what I base it on, right? If your typical power window motor, range between 3 to 4 amps, I'm between 3 to 4 amps, we're good. I don't care less, and have no effective way in calculating resistance. I got more. Windshield wiper motor. 5 connectors here. How to measure resistance to that. Door actuator. This is what opens and unlocks your door. No, excuse me, that's this is a HVAC blend door actuator. This is going to move your mode door actuator. This goes on HVAC system, and as you're pushing the buttons on the dash, this is moving around and moving flaps. Anybody know how to measure that? Get a resistance value on that. And then we'll do one more. That's a door actuator. Here's your door latch, and here's a little actuator which takes power and changes into a linear motion using magnetism to lock. The point I'm trying to make here is I threw these parts on the floor is Ohm's law. Understand, you need about 5 to 8 minutes on Ohm's law and get the concept. To me, Ohm's law is good for explaining the relationship between volts, amps, and resistance, and which one's inverse, which one's aren't. Past that, like I say, I'll have nightmares that I actually spent days on stuff like this in a classroom. And I'm sure if I go to some conference and some guy gets there, starts breaking out this and talks about calculating resistance, and I, stand up and say what I just said here, I probably get burned on a stake. What you need, got a table full of stuff here. There's a $150 amp clamp and a digital voltometer. Then I need to know what is normal current, right? Sometimes it's not published. Quick story. I did a Honda training manual for Honda drivability when I first sold my Honda shop, and people were just starting getting into using scopes and current probes, and so I wanted to establish, it was on fuel injection, so I want to establish, well, what's a fuel pump supposed to be? The current on fuel pump. Well, it wasn't published. Honda didn't see the point in putting in a book. So I come to the shop I used to own, I set up a meter and a current probe and give it to the guys and said, hey, every time a car comes in here, it's in the air, clamp on to the fuel pump wire, jot me down a current number. And so a few weeks later went by, they had about 75 individual current numbers, did put them on a graph, did a standard deviation, kicked out the high and the low, It come with the range 4.5 to 5.5 amps, and went into my manual. So we don't have to wait for the manufacturer to give us information. It's out there if you want to take time. But point of it is, if you know current on a load and you measure it and it's in range, you're good to go. You don't need to be fretting about Ohm's law. Because electric motors are strange little guys. A little extra load on a motor and the current goes up. So then we say, well, if the current's high, is the motor bad? Well, maybe the motor's pumping something and it's extra resistance on the mechanical side. So you got to realize it's not simple as just a resistor that's not getting hot. It's just sitting there. It's a fixed resistance. We don't have very few fixed resistances on a car. We have, all these motors and actuators, and we can get a normal range on those. If it's not published, you can get it. It takes a little time. Focus on that and don't sweat all this.